Welcome to the next in the series of lectures on gas laws. You are going to need a pen or pencil and paper, and you're going to need your calculator. Feel free to pause this video as we go through it or rewind it as necessary. Write down any concept or application questions you have or any clarification questions you may have. Hopefully we will answer them as we go through this video. If not, please make sure that you address them with your instructor before we go on to the next section. Today we are going to be looking at Charles's law. Charles's law is a condition of gas involving temperature and volume, but in this case, pressure is going to stay constant. So in Charles' law, what we're going to be doing today is we are going to be cross-multiplying, which is what you do when you have two fractions or two ratios and you need to turn it into a linear equation. When we do that cross multiplication, we wind up with V1 times the second condition of the temperature is equal to V2 times the first condition of the temperature. So if you need to, go ahead and write this down. That's how we go from two ratios to a linear equation. We're going to cross multiply, and then once we cross multiply, we will cross multiply. What we're doing is we're going to take the condition one of the volume, or one condition of the volume, and the other condition of the temperature. We multiply those together, and then we divide it by the change in the condition of the volume or the original condition of the temperature to find one or the other. Just kind of like we did when we did Boyle's law, how we put them in linear and then we did multiplication. So if I was looking at this equation, if I wanted to know what happens to the original volume, then I would take the change in volume, which is condition 2 of volume, times the temperature of volume 1, and I'd multiply those together and divide them by my new temperature. Or I would divide them by my new volume to get my change in temperature. So it's pretty much the same concept. It is easier to show you, I guess, than tell you. The biggest thing you have to remember, though, is when you are doing Charles's law, because we're dealing with temperature, you have got to convert your temperature to Kelvin to do the math. So remember, we work in Kelvin because we already established that if we worked in degrees Celsius, it's either going to be undefined or it's going to be 0, because degrees Celsius is 0 at standard temperature. So we don't want to have to deal with 0. So we just put it in Kelvin for the whole working of the problem. So according to Charles' law, temperature and volume. If temperature and volume, let me clear this out this way. Okay, if volume over T is volume and temperature, or how they relate to each other, then volume must be equal to T. So if I increase my volume, I'm going to also increase my temperature. And if I decrease my volume, I'm also going to decrease my temperature, because they are what we call proportional. Oops. And they are directly proportional. Key word for this one is that they are directly proportional to each other. So if my volume increases by a factor of 4, then my temperature is going to increase by a factor of 4. If my volume decreases by a factor of 2, my temperature is going to decrease by a factor of 2. All right, so what's important for you is make sure you know the formula for Charles' law, and make sure you know that that formula is Charles's law. So go ahead and take a moment to write it down. Pause the video, write it down, put it on a 3x5 card. I recommend 3x5 cards. Okay, so let's go ahead and get ourselves started. So for Charles' Law, the big thing we remember again is to work in K and report in degrees Celsius. When we start the problem, if I give you degrees Celsius, degree C, you're going to add 273 in order to change it into Kelvin so you can work the problem. Once you finish with the problem, if I'm asking you for temperature and your answer, if your answer is temperature, it is going to be in K, then you take 273 away. And that will bring you back to degree Celsius. Again, notice that Celsius has a degree, Kelvin does not. Okay? All right. Given 240 milliliters of gas at 27 degrees Celsius, find the volume at 42 degrees Celsius. All right, a couple of things we got to look at. V1, remember the given is your first condition. V1 is equal to 240 milliliters. T1 is equal to 27 degrees Celsius. V2 we don't know, so we have to find that. T2 is 42 degrees Celsius. Can I plug and chug that? Not at all. What's wrong with it? Hopefully you figured out that it is in degrees Celsius. So I've got to change that to Kelvin. So what I'm going to do is I'm going to take my trusty dusty calculator. And for T1, 27 plus 273, 27 plus 273 is going to be equal to 300. So T1 is 300K. T2 is 42 plus 273. So 42 plus 273 is equal to 315K or 315 Kelvin. That is where you put your T1 and that is where you're going to put your T2 for T2. And you plug and chug again. Then we're going to cross multiply, make it into a linear equation, and we'll solve for what is unknown. So to set this up, we're going to have 240, which is my V1, over 300K, which is my T1. My V2 is unknown, over my T2. Okay, so what happens when I cross multiply? I'm going to put my 240 times 315, and that is going to be equal to my V2, I'm just going to put V2, times 300, which is my K. And in order to get my V2 by itself, I'm going to divide both sides by 300, which cancels out here. So clear your calculator, open parentheses, 240 times 315, close parentheses, divided by 300, press the equal sign, and let's see if you get this answer. Did you get 252? If so, you're doing fine. And since I asked you for the volume and I gave it to you in milliliters, then you give me back the answer of the volume in milliliters. Okay? Okay. Now you try. Here's your problem. You have 180 milliliters of gas at 43 degrees Celsius. Find the volume at standard. So take a moment and do the problem, and then come back and check and make sure you got it correct. So here I have V1, which is 180 milliliters. I have T1 of 43 degrees Celsius, V2, which I do not know, and T2, which is my standard temperature, which we should know is 0 degrees Celsius. I have to fix my temperatures. So T1 temperature is going to be 43 plus 273, and 43 plus 273 is going to give me 316 K. That's what's going to go here. T2 is 0 plus 273, which is just going to be equal to 273 K, which goes here. And if I set it up correctly, so I have 180 divided by, 316, is equal to V2 divided by 273. Then I cross multiply. And when I do that, I wind up with 100 in parentheses and 80 times 273 is equal to V2 times 316. Divide both sides by 316 to clear it out and get V2 by itself. All right, clear my calculator. Open parentheses, 180 times 273, close parentheses, divided by 316. Push your equal sign. Let's see. Did you get 156 milliliters? Because I gave you milliliters. You should have got 156 milliliters back. Okay. 180 milliliters of gas at 43 degrees Celsius. Find the temperature required to make the volume 135 milliliters. Pause the video. See if you can answer that question. And then press play and check your answer. So let's see. My V1 is 180. My T1 is 43 degrees Celsius. T2 this time is what I'm looking for. My V2 is 130 milliliters. So if I set this up properly, I have to find what my temperature is at 43. So T1 is equal to 43 plus 273. And 43 plus 273 is equal to 316 Kelvin. Okay. So I wind up with 180 divided by 316 is equal to 135, because I know what V2 is, divided by T2. I'm going to have to cross multiply. And when I do that, I wind up with open parentheses, I'm going to do it this way, 316 times 135 is equal to 180 times T2. It's because I want T2 by itself. I'm going to divide both sides by 180. Okay. Clear your calculator. Open parentheses, 316 times 135. Close parentheses, divided by 180, which is going to be equal to 237. And since I'm working in K, it's going to be 237K. Okay, let's check and make sure we got this right. Yep, 237K. Now, am I done? No, because what did I tell you? If you have K, you take 273 away in order to get degrees Celsius. And why would I do that? Because I gave it to you in degrees Celsius. You've got to give this back to me in degrees Celsius. So take the 273K, subtract, 237, sorry. I'm looking at my 273s. 237K, subtract 273, press the equal sign, and that is going to give you your degrees Celsius, which in this case is a negative 36 degrees Celsius. So I went ahead and did the cross multiplication like I was supposed to. I solved for my T2, which was 237K, but I couldn't leave it because I asked you for degrees Celsius. So you had to subtract 273, and that gives you a negative 36 degrees Celsius. Well, can you get a negative 36 degrees Celsius? Absolutely. Remember, degrees Celsius can go as low as a negative 273, and that's it, because you cannot go. A negative 273 is actually 0K, and 0K is absolute zero, and you can't go any further than absolute zero. That's at the point at which all movement stops. There's no more temperature involved. So this is going to be a negative 36 degrees Celsius. Okay? All right. And the answer is correct. Thus ends this section of the lecture on gas laws. If there was any question that we were unable to answer in this lecture, please make sure that you address it with your instructor right away before we go on to the next segment. Have a good day.